In graph theory, a cycle graph is a graph that consists of a single cycle in which the vertices are connected in a closed loop. Now, there's a few interesting properties about cycle graphs that you should know. The first is that a cycle graph is denoted as C sub n, where n is the number of vertices. The second property is that a cycle graph has n vertices and n edges, so it has the same number of vertices and edges. And the third property is that every vertex in a cycle graph has degree 2. This is known as 2 regular. So let's take a look at a few examples of cycle graphs. This first graph right here, which just looks like a triangle, is a cycle graph denoted as C sub 3 because it has 3 vertices. Now we'll notice that this property number 2 is true of this graph. So it has 3 vertices, 1, 2, 3, and it has the same number of edges. So it also has 3 edges. And we can also see that this property is true of this cycle graph. So every vertex in the graph has degree 2. So in other words, every vertex has exactly 2 edges that are touching it. So if we look at this vertex, we can see that it has 2 edges that are touching it. And if we consider this vertex, it also has 2 edges that are touching it. And if we consider this last vertex, it also has exactly 2 edges that are touching it. So this is an example of the smallest cycle graph that you could have. So one in which there are 3 vertices. Now, here's an example of a cycle graph with 4 vertices, and again, we can verify that it has 4 vertices and the same number of edges. So 1, 2, 3, 4 edges. And you can also verify that each vertex in the graph has a degree of 2, or in other words, 2 edges that are incident to it. And here's an example of a cycle graph with 5 vertices, and yet another example of a cycle graph with 6 vertices. Now let's check out a few more examples of graphs and try to determine if they are cycle graphs or not. All right, let's consider this graph right here. Is this an example of a cycle graph? Well, we can tell right away that it has 4 vertices, but they are not connected in a closed loop. So it should be pretty obvious that this is not a cycle graph. Another way of seeing that is that we could just check these 2 properties right here. So if it was a cycle graph, it should have the same number of vertices as edges. So in this graph, there are 4 vertices, but there are only 1, 2, 3 edges, so we know it must not be a cycle graph. And another way to verify that is by noticing that every vertex in the graph does not have a degree of 2. So if we consider this vertex right here, this has a degree of 1, so there's only 1 edge that is incident to this vertex. And similarly, this vertex on here at the end also only has 1 edge that is incident to it. So both of these vertices have a degree of 1. And we know that in a cycle graph, each vertex must have a degree of 2. So that's yet another way of knowing that this is not a cycle graph. All right, now let's consider this graph right here. Is this a cycle graph? Well, it does appear just upon visual inspection that the vertices form one big cycle in a closed loop. And we can also verify that both of these properties are true. So this graph has 1, 2, 3, 4, 5 total vertices and 1, 2, 3, 4, 5 total edges. So it has the same number of vertices as edges, which must be true of a cycle graph. We can also verify that each vertex in this graph does have a degree of 2. So if we look at each vertex, we'll notice that there are exactly 2 edges that are touching each vertex. So this graph happens to be a cycle graph, and we would denote it as C5 because there are 5 total vertices in this graph. All right, let's check out one more example. Let's say we have this graph. Is this a cycle graph? So just upon visual inspection, it might look like this graph does form a single cycle. But if we check that both of these 2 properties are true, let's see what happens. So let's check, does this graph have the same number of vertices and edges? So if we count the vertices, we can see there are 1, 2, 3, 4, 5 vertices. But if we count the edges, we find 1, 2, 3, 4, 5, 6 total edges. So it does not have the same number of vertices as edges, so it must not be a cycle graph. And if we wanted to, we could also verify that this property is also not true of this graph. So each vertex in this graph does not have a degree of 2. And as an example, if we consider this vertex, we can see it has a degree of 3. There are 3 edges that are incident to this vertex. So this vertex has a degree of 3. So remember, in a cycle graph, every degree must be 2. So for this one, we would say, no, this is not a cycle graph. So those were just a few quick examples of how to determine if a graph is a cycle graph or not.